Thank you.
Thank you, Jason.
Well, hello everybody. Good evening. My name is Jason Cordova, and I am a executive board trustee. I've been part of the Astronomical Society for about 2 years now, and this is a project that's been almost 10 years in the making. When I attended the Metropolitan State University of Denver, my senior experience course was a project that modeled, well, the senior experience course was an STK course, comprehensive training, which is basically a physics modeling software, and we did some different things with it, and it led to me publishing a paper which is going to be coming out here in December. Basically, for whether you're familiar with STK or not, it's basically a powerful physics modeling software used by companies such as SpaceX to model mission architecture. Basically, you see what your satellite's going to do when you put it in space. And it is a very striking visual component to it. While I was learning to use this program, I recognized how neat it would be to apply it to archaeoastronomy. So I mentioned it to my professor. He found a student who was experienced with light wave computer modeling, and we basically did a proof of concept, constructed a series of structures in light wave and incorporated them into the STK model. We entered it into the university grant competition for STK, or the AGI, Analytical Graphics Incorporated, their university grant competition. We won an honorable mention that year. The next year, another group of students picked it up and named it after me, the Cordova Project, and took it a few steps farther. What I'm passing around is an article that was published in the Metro magazine, so the University Alumni magazine, about that project that they did. And what they did was we modeled, what Kyle and I modeled was 2 structures in Chichen Itza, Mayan structures in Chichen Itza, central Mexico and the Yucatan Peninsula. They are one of them El Caracol, the other El Castillo, essentially the pyramid and the observatory. And all we were doing was trying to demonstrate that they point to certain celestial objects at certain times of year. What the Cordova project did was did this same thing and used MATLAB as the means to incorporate the model structures into the program. And this is actually a video. Hopefully it'll work. Nope. All right. This is actually on YouTube if you want to see it actually in action. But that's basic idea of what it looks like in the program. And what they did, so essentially El Castillo, or the Pyramid of Kukulkan, is a graphical representation of the Mayan calendar. It not only has these celestial alignments, but also has what is believed to be maybe an observable record comparable to Egypt. In the Cordova project, students discovered that there were some similarities to their model of the Giza Plateau and the Chichen Itza site. Not to say that Chichen Itza itself is as old as ancient Egypt, just again that there may be evidence of an observable record comparable to that time frame. And sun. And what happens is we have a star that we know as Polaris that just happens to be a reasonably bright star in the direction that tends to stay in the near the cardinal direction of north. But that doesn't stay that way over the course of many thousands of years. In fact, it wobbles around and goes to, it takes about 26,000 years to make that entire cycle. Break down that cycle into five, break that into five, roughly 5,000 year intervals. And we get what appears to be intervals that are documented in the Mesoamerican calendar, as observed through the STK model. Now, what sort of evidence do we have to corroborate this? And what can be learned from living contemporary knowledge keepers of those traditions? One of those individuals is a gentleman named Mayan elder and day keeper, Don Miguel Chiquin. He's in 2011, he was welcomed by the Chicano Studies Department at Metro State, and he was granted permission by his Council of Elders to share this information. He actually spent some time going around to numerous universities and other cultural centers. Right around that time, kind of in preparation for the whole 2012 scare, trying to dispel a little bit of that the nonsense surrounding the end of the world sort of thing. And as he shared, there's the Mayan calendar is a very complex system with full of cycles within cycles. One very simple breakdown is as follows. It's basically, you have on the basic level a 260-day count that's called the Tzolk'in, the 365-day solar year that's called the Hob, 52-year cycle, which is referred to as a calendar round, and a 394-year cycle, which is a Baktun, or long count. And what basically was happening in December 21st, 2012, was the end of the 13th Baktun, which corresponds to a 5,000-year or so cycle, and the end of the 13th Baktun, the beginning of a new cycle, which is referred to in this context as the moving from the fourth to the fifth sun in the Mayan world, in the Mayan cosmology. So going back to the Cordova project, some of the things that were corroborated were this 5,000-year cycle, and basically, if we break it down this way, December 21st, 2012 is the winter solstice coinciding with the end of the 13th Baktun. 13th Baktuns are equal to 5,122 years. A full Earth precession cycle takes 25,770 years. An average polar star phase, basically the time it takes for Earth to precess from Thuban to Polaris, observably aligned in the cardinal north direction, and then to Alcura and Deneb Cygni, is 4,549 years. And that is what was observed through the model that we used in STK. This breaks down to 5.66 polar star phases in the precession cycle. So 5 times 5,122 equals 25,610, which is only 160 off from the 25,770-year precession cycle that we observed with STK. Right? So, therefore, with respect to the traditional Mayan teachings, the polar star cycle closely coincides with the Baktun. The Aztec tradition also uses a similar system. The Aztec calendar is referred to as the Tonalpuali, and we also have local representatives of that tradition here who have knowledge of it and teach it, one of which is my teacher, David Atekpatzin Young. He is a co-founder of a group called Atekpatzin, which is an institute of Indigenous scholarship and praxis. And he shares that this is the calendar is not only a way of keeping time, but just a compendium of art, science, and culture. Most people recognize the sunstone as the physical graphical representation of the Tonalpoali, similar to the Mayan version as the Pyramid of Kukulkan is the most recognizable graphical or physical representation of that calendar. The two communities have a lot of similarities. Basically, things were collaborated and borrowed, and very objectively we can refer to the Mesoamerican calendar and inform knowledge between the Toltec, Aztec, and Mayan systems. Some of the main similarities are that the civil calendars bear striking similarities with the 5,122-year intervals and the long count, and again corroborated by STK. Other evidence of Mayan precession knowledge is presented by Susan Milbrath, basically looking at the Pleiades as markers of the beginning and end of the wet and dry seasons and so forth. Tracking their precession over time, Milbrath proposes that in the time of the Toltecs, or who preceded the Aztecs and the Mayans, could have observed this from that time, which is we're looking at about 25,000 years. So from May 7th in 500 BCE, moving on to May 29th in about 1500, right around the time of the conquest. So that expresses that people would have been able to observe this idea of precession and then build it into their calendrical systems. So a couple, just to kind of wrap up the idea and the concept, is that this is a time of tremendous, we have a lot more technology and resources to put into these kinds of studies. The combination of a aerospace physics modeling software combined with archaeoastronomy. We don't need to go grave rob or dig up any graves or disturb sacred sites. We're modeling these. We took satellite images in order to assess the most accurate representations of these structures, import them into the modeling software, and demonstrate these alignments, and corroborate them with living knowledge practitioners of the people who built them. So it creates an opportunity for a lot of collaboration in interdisciplinary science. This is a project that I'm very excited is finally coming together. It's going to be published with the Society for Cultural Astronomy in the American Southwest. The publication is going to be called Before Borders, Revealing the Greater Southwest Ancestral Cultural Landscape, and SCAAS Multimedia Publications. It's going to be available on Amazon Kindle and direct publishing, so you can get a hard copy or get it electronically. And hopefully, once that comes out, I'm happy to, I would love to come back and go into even more detail if you'd like to hear it. And any questions, you can contact me, email, and I'm around. So thank you.
how did those old guys figure that stuff out?
A lot of patience and a lot of paying attention.
So are you getting a master's for this paper or a doctorate?
I'll take one if you want to give it to me.
The paper's written on.
Yeah, pretty much. Yeah, if we could get in, if a university has a program, unfortunately there aren't anybody. There's only one university in the world that grants a master's in archaeoastronomy, and it's an online course. Yeah. So anyway, any other questions? Any other specific questions? Or?
I've got one. So the construction of Mayan pyramids was relatively recent, especially
Correct.
on the scale of a single block tomb.
Yes.
5,000 years. You're talking 1,000 years ago.
Mm-hmm.
Okay, and you're scaling like 5 boxing stacks to 25,000 years.
Right.
Were you able to observe like intermediate points in boxings that
Mm-hmm.
led to them projecting out?
So,
That time scale?
so it sounds like you're asking multiple questions as far as observing it within the STK model versus the actual construction aspect, right?
Sure, I guess, yeah.
Right. So yes, you're correct. It is believed that the pyramid itself was only built maybe 1,000 years ago, total. That is to say that that's not to say that, like I said, it's a physical representation of the calendar. So it's built with the information of that long observational record. The codices, like the Dresden Codex, for example, are recognized with the Venus tables. These are documenting the long observational record of what they did to build and create the calendar. And you see the pictures of Miguel. He has there's these little, they're like cloth pieces that represent different elements of the calendar itself. And that's actually what they use to teach and work with the calendar today. As far as the model, yes, very simply, we could run the model back 30,000 years if we wanted to, and run it 30,000 years in the future to see where that goes. And that's part of how we came to this idea and led us down this path to try to deconstruct it a little bit and find out what's going on there. So that's there's a lot to answer that question with. Yeah. Mm-hmm. Yeah. So, all right. I think that's all the time we've got, though. You do? Yeah.
So you were talking about using light. Is this one of those things where you took data with something that scanned it in certain light frequencies? Or what kind of equipment was used?
Okay. So light wave is the name of the 3D computer modeling program that we use to construct the buildings and import them into STK, which is a physics modeling software. We also used satellite imaging to construct these 3D models in Lightwave, the computer program, in order to import them. Right? Yeah.
All right. Any other questions?